This is Mr. Great at Mr. Great Tech Review Studio, and we are here live and direct once again on our most excellent Arduino tutorial. And in today's tutorial, we are going to present to you tutorial number 16. And tutorial number 16 has to do with what? Potentiometer. And I'm supposed to do that potentiometer before the serial monitor stuffs like that, before tutorial 15. But in any case, I just remember that I have not done it. And okay, is the 17 voltage divider rheostat? Okay, rheostat has to do with linear motion. Potentiometer has to do with rotary, has to do with circular movements. Okay, so let's go and see what potentiometer is all about with your most excellent Arduino tutorial. Arduino starter kit. I always present the starter kit. It's very, very important that you have this. The light is too much on it. Okay, I think you can see it now. The most complete starter kit. Okay, I will post the link below so that maybe others, maybe if you want to also order from the same site I ordered from, I got it from AliExpress. I will still look for it. I will post the link below this video. So you click on the link below this video, it will launch you straight. That should be around that $45 to $50. I can't remember. That should be about 2 to 3 years ago I purchased this. Normally we have been using Arduino, buying single Arduinos board like that, but for this tutorial I discovered that exactly everything I need to teach is actually in this place. For a fresher, for a beginner, everything is here. So instead of you getting these things one, it will cost you more. So it's better you buy them in package like this for a starter. And even if when you are finished, when you have advanced in Arduino coding and programming, you will find out that you still need all these things. So that is it. So okay, so that is by the way for this, and do yourself a favor by getting this. So I will drop it here. When I need it, I will call it up again. So okay, now we are going to do potentiometer. So let's refresh back to our circuit. For our in our circuit, we did something like this, just like you see when we are doing this calculation and circuit analysis, resistors in series and resistors and in parallel. Remember when we did something like this? I'll put it to the camera so the camera will pick it up. Something like this. Okay, using our most excellent Ohm's law. Here we have I equals to V over R, and R equals to V over I, and V equals to I times R. Okay, so that is a very simple electrical calculation, mathematics. And also we talked about the cross multiplication when we use the scale value of Arduino to interpret it to the real world voltage. We did a cross multiplication. That is this. Did a cross multiplication for us to get the real world voltage, where I told you in the analog rate, where you have a scale value of 5 volts is equals to what, 1023. That is it. And in analog right, where we have a scale value of 5 volts is equals to what, is equals to what, 255. Okay, so in analog reading, you have the 5 volts is equals to what, 1023. And when you have 179, like just like you have here, you have 179 here, what will be the voltage, which is the V2? So you do a cross multiplication, and we got our voltage to be what? To be 0.8 volts and approximately 0.9 volts. So that is it. And we just want to complete that tutorial. Complete that tutorial, and this tutorial, let's make it tutorial 16. Complete that tutorial, and with a potentiometer. You all know what is potentiometer. Variable resistor. This is a variable resistor. This is a potentiometer. You can see this in your. You can see it in your this thing, in your. Let me come very close so that you can see it. So you can see this in your radios, in your radio volume controls and the electronic gadgets. This is potentiometer. It's a variable resistor. I will explain how this thing works. You can see the values are written on the body. This is what? This is 50k. You can see it, 50k. This is 50 what? Kilo ohms. 50 kilo ohms. Okay, so I will leave it for the camera to pick it up. Okay, so this is 50 kilo ohms variable resistor. Then you have the one you have in your kit. Let's go to the kit and see the one they put in the kit, and let's pick it up. So you have this as what? As your 10 kilo ohms. Let's bring the shaft that we used to turn it. Okay, so that is it. And what's again? Okay, nothing. So when you have, this is your fixed resistor. I think I handled that tutorial. That should be, I can't remember the tutorial. Okay, so that is it. We have your fixed resistors. This is your fixed resistor, and this is your variable resistor. This and this, they are the same thing. They are the same thing. So the values are written on the body. Just this one, you can see the values on the body. And let me just put it so that you can see it. See, this is 10k. So this is 10k, and this is the, you use a color coding. I'm not going to go into that for now because it's a little bit complicated. Not too much complicated, but it's something that if you learn it, you understand it. It goes easily. If you learn the color coding, you know how to to calculate the color coding. 0 is what? Is black. 1 is what? Is brown. 2 is red. Orange is what? Is 3, and yellow is 4. You know how to, when you have red in band 1, band 2, and see how to do that calculation. So for you to get the value of this, but for now, just use a voltmeter and ohm meter to get the value. Okay, so that is it. So now we are going to use this in place of this. In place of this. Remember the circuit? Okay. Remember the circuit. Okay. How we got the voltage at the center tap here. Remember the circuit. So we are going to use this in place of this. We are going to remove these resistors and we put our variable resistors so that we can also vary the voltage. So because this thing you see now, we always this thing you are seeing now is somehow when you want to the essence of me laying emphasis on this tutorial on the voltage divider, potentiometers, resistors in series, and at the center tap you get the voltage, you get the different values at the different voltage values at every junction of the resistor to get the voltage. I'm trying to simulate what will actually happen when you started hooking up sensors, because actually what the sensor will do, just like the sections will act like analog to digital converters. Very simple. That is what the sensors will look like. The sensors will get sense maybe humidity, temperature, and interpret it and convert it to electrical signals. And that electrical signals has to do with voltage, and that voltage has to vary. Sometimes 0.5 millivolts has to vary from millivolts to volts, and that is how it sends the voltage to the Arduino pin, to the analog read pin, that is A0 to A5, and it takes it, and the microprocessor will interpret it either to on the relay or to off the relay, to make the relay or to break the relay, whatever, to latch the relay, or whatever terms you're going to use. So that is it. That is how this thing is going to work. So if you don't understand this circuit analysis, if you don't understand this tutorial, do yourself a favor, watch it and over again, over again, so that you will understand this. Because your journey on hooking up sensor in Arduino begins with this tutorial. So let's go ahead and hook up this. So it's very simple. So I will explain how this potentiometer works. It's very simple. This is potentiometer for you, and this is how it works. Okay, so you see you have 3 legs. you have 3 legs in potentiometer. You have 3 legs in potentiometer. I think I will remove this shot and bring it short so that can be also capture. So you have 3 legs here. You have 3 legs here. So this is, and this one you have 2 legs. So this potentiometer is just like a 2 resistor connected in series. Just like I told you, it's exactly what we did in this circuit. 2 resistors connected in series, and the center tap is this. You understand? You understand? The center tap is this, which is here. Why these 2 ends are these 2 ends? These 2 ends are these 2 ends. Okay, so now when I need my voltmeter so that I can be able to illustrate this very well. I need my, okay, I think I'm getting the most excellent shot. Okay, I love this camera I'm using for this. Actually, I swapped the camera so that I can, this one, the zoom is much, it goes far. This is times 60. So it has a digital and analog, digital zoom and other zoom. So you can go very far and pick. The other Canon is somehow slow in picking, in zooming objects. But this one can zoom as far as 1 kilometer. So it has a powerful lens. The optical lens is very powerful. That should be times, is it times 20? Okay, that is by the way. Okay, so let's go and see. Now you see when you measure these resistors, you have a fixed value. Let me just switch it to resistance. So you measure from here to here, you have a fixed value. This is 5 watts. I have 490 ohms. Okay, I have 491 ohms. Let me unhook this stuff so that they will not add up to their resistance, and they keep Arduino one side. Yeah, finished the work for now. Okay, so I'm here with this. So when you measure this and this is the 470 ohms. I have a 4 watt, 467 ohms. Then this should be the 100 ohms. I have what? I have 99 ohms. And at the extreme end of it, end to end, I have what? The end of it, I have what? I have 568 ohms. Okay, so that's 570 ohms supposed to be at a fixed value. Okay, so this is a fixed value of this resistor. It does not change. It does not what? It does not change. Now this is how, let me draw the circuit diagram so that you understand this. So in this one, you have something like this. Okay, you have something like this. So that is why in the symbol you have it as this level. You have this as your what? As your what? Variable resistor as a symbol. So this center marks the center tapping here. So here is what you have here. You have the center, you have these 2 ends, which is these 2 ends. So if this is 5K, 10K, just like you see, it is 10K. If it is 10K, the middle here should be what? Should be 5K. So you have 2 5K joined together. So now when you turn it at the middle, you have what? At the center of it. At the center of it, this should be the last of it. Okay, I'm coming. Okay, at the center of it, at the center of your rotation, you have what? You have what? From here to here, you get 5K. From here to here, you get 5K. From here to here, you have what? 5K. and from here to here you have what? 5k. So that is it. Now when you start moving from here, you start moving like this. This is where your pointer is. So from here to here. So when you start moving towards this side, you are increasing the resistance. Maybe this is 12 o'clock. This is 12 o'clock. Let's go. This is 12 o'clock. 12 o'clock. 12 o'clock. So this is 12 o'clock. So when you start moving downwards to maybe to 12:15 here, maybe this will start increasing. You may have about 5k. I mean, you might have about 8k. So now it becomes this one from here to here now to the center tap will be around 8k. 8k, because you are shifting, you are shifting, you are shifting, you are shifting till you have a full-blown what? You have a full-blown what? You have a full-blown 10k at this point when the pointer is facing this side. So now the pointer, if I shift it like this towards the end, so from here to here you have what? 10k. Then from this one to center tap you have what? 0k. So that is how that is how it works. Now let's demonstrate it so that you see what I'm saying. So this is center of it. At the center of it, let's measure it. Remember, let's use this to measure, and let's put it this way. Okay. Okay, so at this point, so let's measure here and here. We have what? We have 4 points. That is 4331 ohms. That is 4,331 ohms. That is 4 point something ohms. So just like I told you, at the center you have what? You have 5 ohms. So let's make it 5, a little bit 5. Okay. Okay. So you have 5 at the center. Likewise, this one you also have 5 at this leg when I shift leg. So you see it's not exactly 4 points, about around 4.6 kilo ohms. So at this place you have 5 ohms. So now if I move this towards the end, I will have a full-blown 10 kilo ohms. That is it. So you can see I have 9 points. You are not seeing the point, the decimal point. Let me bring it closer so that you see the decimal point. You see it, 9 points. I have to drop something so that you can see it very clearly. Okay. Okay, so towards the end, you see it, you have 9.5 kilo ohms. So I will go further and bring it. You see how the resistance is changing? It's changing. I'm at the center now. Okay. Let's make it exactly. Okay. This is 5.032 ohms. That is 5.0232 kilo ohms. That's 5,031 ohms. That is 5.031 kilo ohms. So that is it. So when I go towards this end, I will hit 0. You see it is beeping now, 0 ohms. Towards the end of this leg, I will hit 0. And this one, this leg turns what? It's a full-blown what? 10 kilo ohms. 9.5. It will not exactly give you because of some tolerance. Sometimes you use your meter for a long time. You need to recalibrate your meter so that you will give accurate results. So maybe lack of recalibration, the meter will be giving some. We have some differences, some errors. So that is it, but it's 10 kilo ohms. Okay, let's take it at 9.5 kilo ohms, but the resistor is reaching 10 kilo ohms. Okay, so that is it. You see it, At this point, this is what 10 kilo ohms. So if I start coming, this place will be reducing. Coming towards it, it will be reducing. So that is it. So that is how the variable resistor works. That is how variable resistor works. So we are going to use it to replace this circuit. So these two legs, these two end legs here, I will come close so that I will come close. Okay, so these two end legs here, okay, these two end legs here is this two end here. You can see it. You can see. Okay, just to get the most shots. Okay, that is it. Is this two end here? This and this is this and this. So this center tap here is this center tap here. So that is it. So we are going to rewire our circuit so that we will come to, we'll just get this. Okay, so that is by the way. Okay, so now we'll use the same you use the same program to run it. The same program we use in the analog rate. We use the same program to read the same voltage so that we can be able to understand it. So we'll use the same program again. If you still save the program in your system, so let's go ahead and get it, and so that we can be able to play it. Okay, so here we have int read pin A5. We have float V2. Okay, we just V2 should not be 0 again. Sorry, V2. We just have to declare V2 is okay. So that is it. Okay, int RV. This is the read value. Int long D. I just want to go back to this program, to this code. Okay, pin mode, you have read pin is equals to input pin, and the serial begin dot baud rate of our serial monitor. Okay, void loop, we have RV equals analog read equals read pin, which is this, V2 which is equals to this and that. Okay, this is V2 which is equals to this and that. Okay, serial print in line delay long D. Okay, so that is it. So now we are going to repeat this so that we can now read and see. Can you see it? Okay, so I will bring my Uno board. I will hook up plus to plus. I hook up, this is my plus and this is what my minus. I told you so that you see what I'm doing. This is my plus and this is my minus. This is my minus. This place goes, sorry, this is my minus and this is my A5, goes to the center tap. Okay, that is it. It's very easy and very simple. So we hook up okay, you can see it. You can see it. Can you see what I did? Okay, so very simple. Okay, so now we can I can still run it with my multimeter, we can now see. Okay, let's just do it with Arduino. Okay, so let's check our tools, our ports. Okay, COM3, Arduino recognize, board, Arduino Uno, confirm. Okay, now let's download it and see. Let's upload. Okay, good. So let's now open our serial monitor and see what is happening. Oh, okay. We have what? Okay, let's clear again and see. Clear output. I have 2 points. Where am I getting 0? Ah, you're not seeing. Sorry. You're not seeing. You're not seeing. You're not seeing. Good. Okay. Okay, let me remove this and remove it so that. Let me remove it and put it at ground pin. Let me upload again. Okay, let's open serial monitor. Okay, I have 0.000. Okay, now let's go to. Okay, I have 5 volts. I have 5 volts. I mistakenly hook it up on the wrong pin. That could have damaged my Arduino. Very sorry for that. Okay, so you have this. So here, these pins are not. This one has pulled out already. Use another one. Use another one. Use another one. Use another one. Okay. These are not strong. Okay, so okay, I have 5 volts at the center. I have, okay, I have what? 2 points. Okay, at the center tap I have what? I have 2 points. What? I have 2.4 volts. 2.4 volts. So I'm going to vary now. You see how the voltage will be changing. Sorry. Okay, so as I vary it, you see there will be a change in voltage. Okay, I have 0 volts. So okay, I have 1 point. Okay, let me go again. I have 3 volts. 3 volts. I have 3 volts. Let me go again. I have 4 volts. I will continue until I get full-blown 5 volts. Full-blown 5 volts. I have 5 volts. I will stop. So that is it. So at this 5 volts, that means the resistance on this leg, on this is what? Is 0. Is 0. So that's why I'm getting 5 legs. I'm almost to the end of it. Almost to the end of it. I'll get what? 5 volts. So I will go again to the middle of it. I will go to the middle. I will go to the middle. I will have 2 points. 2.4 volts. I will continue again. I have 1.8 volts. I will continue again. The resistance is increasing. It's increasing. I have 1 point. Let me do it so that I will get 0 point. Okay, I have 0.8. Okay, so that is it. So now you have seen the work of a potentiometer as a voltage divider, how we can use it, and it's exactly the same thing we did with this. It's exactly the same thing we did when we are using this. When we are using this. It's exactly the same thing. So I'm using potentiometer, that is a variable resistor, to achieve the same process. In this place, you see, you can now vary and get different what. This is the disadvantage of this variable resistor. You can vary and get different values. So when you want to adjust, maybe you want to adjust your set point, you see, you use this variable resistor to adjust to get your set point. What it's just doing is that it's dividing the voltage, it's varying the voltage, sending signals to the microchip. It's just varying the voltage. That is what it's just doing. Just varying the voltage, adjusting the voltage signals. That is it. The sensor values, maybe your sensor is not reading accurate at 100 degrees. Maybe you are getting 99, you're getting 99 degrees, maybe you're getting 95 degrees. So you add a variable resistor for you to get your set point. Use it to vary so that you get your set point and the rest of them. So that is the work of this variable resistors and what you can use variable resistors to achieve. I believe that this tutorial makes sense, and if it makes sense, you like and share so that others will benefit too. I'm wearing my headset so that I can hear myself, because in my last previous tutorial I discovered that this volume, the sound is very low, and because I'm not wearing a headset, I couldn't monitor it and know when I'm off. Okay, so that is it. So I believe this tutorial is okay, and I've done justice to that. So send me your comment on the comment section so that I will also improve. If there is anything you don't understand, or there's angle you want me to improve or to throw more light on it, I'm a human being. If you didn't remind me, I will not remember it, so I can throw more light on that angle. Or there is area you want me to correct in our production quality or our tutorial, you can send me your request, and my email is open for everybody. My WhatsApp is there, Instagram, Twitter. You can send me through the comment section. You send me your request and make your comments there. I'll put all of them into consideration, so that to make this tutorial better, so that you understand better, and you will also be a master of Uno programming, Uno coding. Okay, so that is it. If this tutorial makes sense to you, please like and share so that others will benefit as you are benefiting. Thank you very much, and God bless you. I remain your one and only Mr. Great, here at Mr. Great Tech Review Studio, bringing technology to your doorstep. Thank you. Bye-bye for now. God bless you.